Okay, let us start with the unit 3. So in the unit 3, the first topic is the Chebyshev differential equation. Okay, Chebyshev is a very old, I think so, 18th century mathematician, and due to this name, this differential equation is there, and the solution for this differential equation is known as the Chebyshev polynomials, and that polynomials actually gives you the best approximation of a continuous function, which is very interesting topic to study. So what is this Chebyshev equation? Differential equation is of this form: 1 minus x square y double dash minus x y dash plus p square y equal to 0. Now the question is to calculate, or obvious question is come into the mind: what would be the solution of this Chebyshev equation? So to calculate a solution for this Chebyshev equation, we need to see what are the ordinary points for this. So this equation can be written as y double dash minus x upon 1 minus x square y dash plus p square upon 1 minus x square y equal to 0. Comparing with y double dash plus p of x y dash plus q of x y equal to 0, we have p of x is equal to minus x upon 1 minus x square, and q of x will be p square upon 1 minus x square. We should note that this p of x and q of x are analytic at the point x is equal to 0. We note that p of x and q of x are analytic at x is equal to 0. In fact, they are analytic except x is equal to plus or minus 1, because this has the two roots, that is x square will be 1, so hence x will be plus or minus 1. So except plus or minus 1, this p of x and q of x are analytic, but in particular it is analytic at x is equal to 0. So what we can say, this x is equal to 0 is the ordinary point of equation 1. What is the equation 1? Is this. This we can call it as equation 1. And since it is the ordinary equation into this form, sorry, ordinary point into this form, we can put, or the solution as per the theorem or as per the theory, the solution is of the form y is equal to summation n running from 0 to infinity a n x raised to n. That is, in the power series we have the solution. So we will put this y is equal to this y dash. From this we can have summation running from 1 to infinity n into a n x raised to n minus 1, and y double dash will be summation n running from 2 to infinity n into n minus 1 a n x raised to n minus 2 in equation 1. We get y double dash, we can substitute into this equation, is this equation we have, that is 1 minus x square summation n running from 2 to infinity n into n minus 1 an x raised to n minus 2, then it is minus x into summation n running from 1 to infinity n into an x raised to n minus 1 plus p square. It was p square y. So it is summation n running from 0 to infinity an x raised to n equal to 0. This can be separately right. That is summation n running from 2 to infinity n into n minus 1 an x raised to n minus 2 minus summation n running from 2 to infinity n into n minus 1 an x raised to n minus summation n running from 1 to infinity n into an x raised to n plus p square summation n running from 0 to infinity an x raised to n equal to 0. Now first we need to convert this, is the power will be the same. That is the first task we are doing. Here the power is n minus 2. So in this summation, in the first summation, all of them is this x power n. So I need to change this as a power of x power n. So for that I can replace this n minus 2 as n. So what is the objective? What we will do is replacing n minus 2 to n into the first summation. So this summation will start with now 0. So that's why we'll have summation n running from 0 to infinity. So if n minus 2 is n will be n plus 2. N plus 2 into n minus 1, so it is n plus 1. A n plus 2, that you can see from this, x raised to n. And all rest of the things are as it is. So this is minus summation n running from 2 to infinity n into n minus 1 an x raised to n, that is this, minus summation n running from 1 to infinity n into an x raised to n plus p square into summation n running from 0 to infinity an x raised to n equal to 0. That is the last term we have. Now I want that some index will start with the same index. The highest will be 2. So I must write down for n equal to 0 and n equal to 1 term separately. What are the terms of n equal to 0? So that are the two terms we have. The first one is here. The second one is here when I substitute n equal to 0. That is a constant term. So when I substitute n equal to 0 into the first summation, we'll have a2 into a2, that is n equal to 0. So 2 plus 0 plus 2, 0 plus 1, a2, a power 0, that is a constant. There is no term n equal to 0 here. Here also. The last one we have plus p square a0. This is the constant term. Now when n equal to 1. So here when I substitute n equal to 1, this is 3 into 2, that is 6 a3 into x. There is one term of x is also here when I substitute n equal to 1 here. So it is plus a1, sorry, not plus, but it is minus a1 because due to this minus sign, minus a1 plus when I substitute n equal to 1, we'll have p square a1 x. This is the coefficient of x is there. Next, it will start with summation n with running from 2 to infinity. This is also 2 to infinity. Now all the summation will change to 2 to infinity. So that's why plus summation n running from 2 to infinity. Inside bracket we have this a n plus 2, n plus 1, a n plus 2, minus this term is there, that is n into n minus 1 a n. This is minus n into a n, and this is plus p square a n into x power n equal to 0. Now equating the powers of x, equating the powers of x, we get the constant term is equal to 0, that is 2a2 plus p square a0 is 0. The next will have this quantity will become 0. So that will gives you 6 a3 minus a1 plus p square a1 is 0 into this one. And then lastly we have this all the terms having the an, so I can take an common from that and we simplify that quantity. Let's see what we get. So the coefficient of an plus 2 is n plus 2, n plus 1, an plus 2, then it is minus. You can take this minus out. Inside bracket you will have n square minus n, because this is n into n minus 1, n square into minus n, and this if you take minus out, so this will become plus. So plus n minus p square into an equal to 0. So this will implies a2 will be minus of p square by 2 a0. This will implies a3 will be, we just take out this a1 from this, so this is p square minus p square plus 1 upon 6 a1, and the last equation will give you an plus 2 will be n square minus p square upon n plus 2 n plus 1, and this recurrence relation is true for n equal to 2, 3 up to so on. Explicitly, if we write down all the terms for n equal to 2, 4, 2, 3, 4 and so on, we will have a4 if I have n equal to 2 here. Sorry, here it is, I forgot to write down an. So a2 n equal to 2, if I substitute, then it is a4, that is 2 square minus p square upon 2 plus 2, that is 4 into 3 into a2, but the value of a2 is this, so that's why it is 2 square minus p square into minus p square upon 2 is there, so it is 4 factorial I can say into a0. The next term is a5, that is n equal to 3 if I substitute, that is 3 square minus p square upon 3 plus 2, it is 5 plus, sorry, into 4 into a3, but the value of a3 According to that, it is 1 minus p square. So I can say it is 3 square minus p square into 1 square minus p square upon 4 into 5 into this 6. 6 is 2 into 3. So I can say it is 5 factorial. A1. Same way, we can go further. That is for n equal to 6. I can write down that is 4 square minus p square. That you can observe for n equal to 3 if I substitute. Sorry, 4 I have to substitute. So it is 4 square minus p square upon 6 into 5. 6 into 5 into a4. But the value of a4 is this. Hence, we can have this is 4 square minus p square into 2 square minus p square into minus p square upon 6 factorial into a0. Same way you have a7, and similarly, what is the pattern you can see from this a2, a3, a4, a5, a6? You will have, so similarly we have in general. So you can just observe that for even terms you will have different thing, and for odd term you will have different. So for a4 you will have different pattern. So if this index of a is an even number, then it is a different pattern, and for odd it is a different pattern. So that's why we'll write that is separately. That is, I can say a to n because it is an even number. For a to n, you just observe that is, this is 4, then it will start with 2. It is 2, then it is 0. This is 6, so it will start with 4. So in general, it will be 2n minus 2 square minus p square. Then it is 2n minus 4 square minus p square up to so on, 2 square minus p square and into minus p square upon 2n factorial into a0, and this is true for any value of n from 1 to infinity. And what will be the a to n plus 1? You can just observe for a to n plus 1. For a3 it will 1 minus p square. For a5 it is this. It will start with 3 square. So 2 less. So again it is 2n minus 1 square minus alpha square. Sorry, a p square. Then it is 2n minus 3 square minus p square. Up to so on. 3 square minus alpha square, 1 minus alpha square upon 2n plus 1 factorial into a1. And this is also true for n running from 1 to infinity. And if I substitute now this for even number and odd number into our series, into the power series, therefore the solution is y equal to, we know that is summation n running from 0 to infinity a n x raised to n. Now we need to substitute this value here. So I may separate this summation or this summation, that is for even number 2n x raised to 2n plus odd numbers, that is n running from 0 to infinity a to n plus 1 x raised to 2n plus 1. So for even we have this, and for odd we have this, and hence we have, I can say it is the solution which will be having the two portion, and both of them are linearly independent. So that we need to show. So ultimately what we can say is some C1 or this an, sorry, a to n, if I write down from this whole thing into a0, if I take this a0 out, so I'm not writing now all the quantity here. Instead of this an and this a to n, the previous quantity will be there. So the solution will be this a0 into y1. If I call it that series as y1, and a1 into y2 is the another, where this a1, a0 and a1 are arbitrary constant, which is the solution of Chebyshev differential equation. Okay. If this value of p is an integer, then what will happen? So now the question is, if the value of p is an integer, then what we can say about this solution? What is this a to n? If this is an integer, some integer is there, let's say capital N, then what will happen? Let me write down that solution, or a to n here. What will be the a to n we have? The a to n, the value of a to n, we can have it is 2n minus 2 square minus alpha square, sorry, p square, two n minus 4 square minus p square, up to so on, 2 square minus alpha square minus alpha square upon 2n factorial into a0. Now let us assume that, suppose that this p is an integer. Okay, then there will be two things: either this p is an odd integer or even integer. Let's say that, suppose that p is an even integer. Let's say the value of p is 2n. 2n will be the value where n is some integer is there. It is an even integer. Then according to this, what will be the a to n plus 2? What will be the a to n plus 2? This is a to n. What will be the a to n plus 2? According to this, you have to subtract 2 from this index. That will be the first term. That is, it will be 2n square minus 2n square. So in that case, you will have, we know that this a to n plus 2 is 0. Have you understood this?
No, sir.
You just, what is a to n plus 1? You just substitute instead of n, a to n plus 1. Sorry, a to n plus 2. Instead of 2n, we have now 2n plus 2. What will happen? This value will become 2n plus 2. Minus 2 is there, so this is cancelled out. So what is this bracket? It is 2n square, and p, value of p is also 2n, we have assumed. So that is 2n square minus 2n square is there. So this value will become 0, and all other values are there, but 0 into anything will become 0. So a 2n plus 2 is 0. So that means this y1 which we have here into the solution, that means this summation is always only goes to kya sudhi, just from this summation is only goes to n equal to 0 to n. It will goes up to n. Afterwards a to n plus 2, a to n plus 4, all the terms will become 0. ये बद्दे term 0 thase. Understood? That means this y1, that means this y1 is a polynomial of degree 2n if your p is an even integer. If p is an odd integer, then what will happen? Can somebody tell me? So the next, suppose that p is an odd integer. Odd integer means p, the value of p is 2n plus 1. Then what will be the value of a 2n plus 3? This is a to n. So if I replace this, instead of a to n, if I replace by 2n plus 3, then this will be 2n minus 2n plus 1. This will be 2n plus 1. And the value of p is also 2n plus 1. So this is the value will be 0. So in that case, you will have a 2n plus 3 will be 0 for every n greater than or equal to n. If I, from this, all the further step means all the further value, for that you will have, this will imply a 2n plus 3 will be 0 for every n greater than or equal to capital N. So in this case, what will implies, or what we can say, that which implies that y2 is a polynomial of degree 2n plus 1. Now you must also observe that if p is an even integer, then the next value, that means this y1 is an polynomial of degree 2n, and if it is an odd integer, then this y2 is a polynomial of degree 2n plus 1. So ultimately what we can say is this, that if this p is an integer, then the solution of this Chebyshev equation is a polynomial of degree n, and that polynomial is called the Chebyshev polynomial. Understood? That if so, ultimately what is the statement I can write is, if p belongs to n, that is the set of all natural number union 0, then either y1 or y2 terminate. That means either y1 or y2 become a polynomial, and if this polynomial is multiplied by a suitable constant, then it is said to be Chebyshev polynomials. So this is actually a definition of Chebyshev polynomials. Here I am giving you some exercise to deal with. I want this Chebyshev polynomial for the case p equal to, so I want this Chebyshev polynomial for p equal to n, which is 0, 1, 2 and 3. So can you able to find out what is this Chebyshev polynomial? This is the value you will have. If I take p equal to 0, 1, 2 and 3. So I need to have this value of y1 and y2. So can you able to find out yourself that value? For example, I'm able to calculate for p equal to 0. What is the p equal to 0? You will have p equal to 0 માટે શું થશે? What will be the p equal to 0? For p equal to 0, what will happen? What is a to n? What is a0? According to this one, n equal to, if you substitute p is 0 now, so what will be the value of a2? a2 ની value શું થશે? What will be the value of a2?
0.
0. What is a4? That is also 0, because a2 is 0, so a4 is 0, and so on. So in general, I can say 2n is 0 for every n greater than or equal to 1. So what is your y1 in that case? What is y1? Is this series summation an 2n plus 2n, that is a to n. In that only one term is survived, that is a constant term. All other, so n equal to 0 mate a0, then it is a 2 x square, but a2 is 0, a power a4 x power 4, all the terms having a2 a4 all the 0, only a0 is left. So what is the value of y1? It is 1. So that is the constant polynomial for p equal to 0. So in similar manner, I want what will be the polynomial for p equal to 1, p equal to 2 and p equal to 3. I will give you 5 minutes to calculate this. I want that you can calculate for this.